that that exponential page looked yesterday, right? I just like how they organized it. So I kind of cheated and I turned it into log, but yeah, it does look really crappy with all the things I cut and paste on there. So I will totally own that, right? But again, I couldn't get it exactly as I wanted. You can tell I kind of took some things out, changed some things, right? So, and again, that came out bad after I moved it. So log base b of x, that's our log, right? Am I okay with just saying b is greater than 0? Our base is greater than 0, right? That covers no negatives. One thing I have to add. What do I have to add? B can't be what? Right? Connor's doing this, right? So B can't be 1, right? B can't be 1. So we got to remember that our base has to be 0 to 1, right? 0 to 1 for our decay and greater than 1 for our growth. Can't be negative. You're going to also remember, right, and definitely by these graphs, the argument of the log has to be positive, right? Argument of the log has to be positive. I cannot have a negative value after the log. So B represents the base, right? And that is telling us when it is a growth or a decay. Same deal as exponential. It is always increasing, decreasing. It is always concave up, concave down. So no extrema, no inflection points. I made a mistake on the log ones, right? Because we're going to have one of these logs either go in a positive or negative infinity, right? But one of them is always going to have that vertical asymptote too. So you need a positive or a negative for your superscript because it is only going to be on one side of that vertical asymptote. Okay? So again, it's ugly, but that is online as well. Again, I think that's all prior knowledge. So I put a whole, and that's all the same stuff, right? What we talked about. I put a whole bunch of graphs in here. So you are going to kind of see me kind of skipping through a whole bunch. I put them here in case we needed them so we could have some problems. What I'm not going to have you do, so in Algebra 2, you would have taken a -2 for your exponential. You would have gotten a quarter. You would have found all of these points for your exponential. And then you would have said, okay, I'm going to go find the inverse. I'm going to flip all of those points and graph them. Right? You guys remember doing that in Algebra 2? Yes? Right? We don't need to do that. So we just need to know where the function is to analyze it. So I put some really easy ones up here, right? So I've got a log growth. I've got a log decay. I've got a natural log. What's the difference with a natural log? Is it a growth or a decay? Growth or decay for natural log? What do you think? Growth or decay? Right? Parker's saying growth. Why growth? What is the base? E, which is that 2.718281828, right? That we did yesterday. So our natural log, right, is a growth, okay? So what I wanted to do is I kind of want to find it. I wanted to find like maybe a harder one, right? So again, I'm just going to make one up because I think I can make them up harder and analyze it. So let's say we're starting with log base 2 of x, and I want you to rewrite something based upon these transformations and then analyze it. So since I'm changing it, we probably need to change the limit lines a little bit, but I want you to look at domain, I want you to look at range, I want you to look at the limit lines, the asymptote, the intercepts, the concavity, right? And I want you to sketch it. All right, so let's go. And I was going to write it a little differently too. Let's do a vertical translation of 1, right? Because some of you guys had questions when I used that notation on your quiz. You're like, is it up or down? If I give it to you as a positive, it's up, right? If I give it to you as a negative, it's down. So vertical translation of 1, vertical dilation dilation and a left 3. Okay, so I want you to write a new function, right? Write a new function and then analyze that function. Write a new function, then analyze that function. No help here. Write it and then analyze it. Okay, so you're writing a new function, you're sketching it, you're analyzing it. I want you to do all of those parts of analyze. You don't necessarily need to find the inverse right now. We're remembering that logs and exponentials are inverses. And just a sketch, so you're able to analyze it. Do you guys agree with the function? The function okay? 3 in the front, 3 in the back. Input negative 1/4 x minus 3/4. Is that okay? All right, are you guys okay with location of final graph? Right? Again, it's just a sketch, so I'm not like saying that. That's why I put not to scale. It is just a sketch. You're mainly kind of looking for location. Any issues with the final function or the location? Final function or location?
Could you go over how you got that?
How I got to this part? Okay. So if I do these two outputs, those aren't that bad, right? So vertical translation, I'm going to go +1. And then a vertical dilation of 3, I'm multiplying by 3, multiplying by 3. So those are my outputs, right? And I don't know if you were watching while I did it. I kind of did this input. So a y-axis reflection would be a -x. A horizontal stretch of 4 means I'm going to plug in a -1/4. And then if I go left 3, I'm plugging in an x plus 3. So I distributed that out and got -1/4 x plus 3. Okay? All right, Sam, how about domain? What do you think? Negative infinity to -3. Keta, how about range? Negative infinity, positive infinity. Let's go down to asymptotes. Noah, asymptotes? X equals -3. Right? How about concavity? Gabe, concavity? Concave down. Right? Molly, what does concave down mean?
Decreasing at an increasing rate.
Good, decreasing at a decreasing rate. So the function is decreasing, and concave down means that the rate is also decreasing. Okay? How about behavior? So Connor, give me this behavior. Give me that behavior.
And the function approaches infinity as x approaches -infinity.
Good. And Anaya, how about the other one? This one.
The function approaches -infinity.
Superscript positive, right? I'm sorry, superscript negative, right on the left. So you got to make sure on these you're doing those superscript positives and superscript negatives. Okay? How can I get the domain algebraically? How can I get the domain algebraically? Domain algebraically. Max, what do you think? What can I do?
You just figure out when the log inside the log is 0, because that's when it switches to being like.
Okay, good. So I'm going to change it. Oh, what was the inside? I just erased it. -1/4 -3/4, right? So instead of just putting it 0, right, because that doesn't give you a direction. Thank you. Is that it? Right? Instead of just putting it when it's 0, because that doesn't tell you to go to the left or the right, right? So the argument needs to be greater than 0, right? So don't just worry about where it's 0, but where it's greater than 0. So if I add 3/4 to both sides, and then I'll just multiply by -4. When I multiply by -4, I have to make sure I'm flipping the sign, right? You multiply by negative. So that's how you could get the domain algebraically. Okay, there was one more thing I wanted to do. Oh, x and y intercepts. Okay, so x and y intercepts. Lauren, which one's easy? X and y intercept. I would say the y-intercept is a little easier on this one. Why? Because there's none, right? So y-intercept, if we wanted to do the y-intercept is when we plug in 0. It would be helpful if I had the function to be able to do it. Was it right there?
Yeah.
All right, so 3 log base 2 -1/4 x minus 3/4 plus 3. So if I wanted to find the y-intercept, I'm going to plug in 0 for y. I'm sorry, plug in 0 for x. And when you plug in 0 for x, you get -3/4. Right? So grab your calculator. Grab your calculator. in your calculator, do log base 2 of -3/4. So I'm kind of checking a few different things as I'm asking you to do the calculator. Log base 2 of -3/4. Log base 2 of -3/4. What does it give you as an answer? Not real, right? So I'm making you do that to make sure you're understanding how to put a log base in your calculator, right? So if I do this part in my calculator right there, just that part, you should know that there's no answer to that, right? Because the argument is negative. How do I do that in my calculator? How do I do that in my calculator? Whoops. What do I do? Anybody? Math, right? And you look for your log base. So math, log base, it's a base of 2 of, I'll just put -0.75, and it tells you that there's no real answer. How about if your calculator did not have that log base in it? How else can you do it? How else can you put that in your calculator if it didn't have the log base? Again, these are one of the properties that you're reviewing tonight. How do we do it? Anybody remember? Connor?
Is it log 10 of argument over log 10 of base?
It doesn't have to be 10. It can be any base, but you're right, 10 works because that's what I'm going to use my calculator, right? So log of the argument over log of the base. So that means if you just don't have that log base in your calculator, that is called change of base, right? So that's a property that you're using tomorrow. I'm sorry, tonight's homework. So then x-intercept is x comma 0. Donovan, is there an x-intercept?
Yes.
Right, it crosses. We can see that from the graph. So I'm plugging in 0 for my y. And I need to solve it. So, Claudia, get me to solve that. What am I going to do? What am I going to move?
You can subtract 3.
Okay, so subtract 3. Gets rid of that. Keep on going.
Divide by 3.
Good. Divide by 3. That's what I'll rewrite. -1 equals log base 2 of -1/4 x minus 3/4. Maxwell, pick it up from there. How do I isolate the x? I've got my log isolated. So how am I going to isolate that x? Change what? Change what, guys? Make it exponential, right? So you go base to what the log answer is with the argument. Right? So that's what? A half equals -1/4 x minus 3/4. You guys solve that. I don't care, decimals or whatever, it doesn't matter. So you guys solve that, please. Make sure your answer makes sense based upon the picture. Make sure your answer makes sense based upon the picture. What'd you guys get? Donovan Connor, what'd you guys get? -5? Right? You guys got -5? So again, you make sure that makes sense based upon your picture. So does it look like it could be -5? Sure it does based upon your picture. Okay, is that okay? We didn't really get to do one of those exponential. So let's do an exponential one of those, right? And do all of the same stuff. Okay, so let's do an exponential one. Same deal, what I want you to do. I wanted to make it bigger, that didn't work. So I'll just kind of keep all that stuff up there. All right, so let's do the same thing for exponential. So let's start with 2 to the x. Let's go. I made this one really bad. Last class we had like 72s and 36s, so I'll try to be better. Let's go right 2 or horizontal translation of 2. Let's go y-axis. Let's go vertical dilation of a half. Let's go up 4 and an x-axis reflection. So I want you to write a new function. Simplify the new function if possible. Sketch it, analyze it. Sketch it, analyze it. Yeah, that one's not a bad graph. So write the new function, sketch it, analyze it. X-axis, I'm sorry, x-intercept, y-intercept as well. Why do you have to use one? So you can combine them. Combine the half and that's 2. Are you guys good with the function? This is what I got for the function once it was simplified. Is that good for the function once it was simplified? Is that okay? I'll check for you in the calculator. Yeah, I think I'm okay for you. Check your steps. Make sure you do what? X-axis and y-axis? So did you start off as a group?
It says 0 until it goes up.
Oh, no, I'm done.
Right, which one do you start with?
I started with.
Yeah, it should be started as a group, right? So that means it's just gonna flip over, right? Do you guys agree with my sketch? Do you agree with my function? This was your function. what's your y-axis sensing? Actually, my limit lines are okay on that. All right, what's the easiest thing on all of these? Easiest item. Easiest item. Domain, right? So domain negative infinity to infinity. All right? And you should pick another one. What else do you want to do?
Range.
Range? Good.
Negative infinity to negative 4.
Good. -4. Alex, pick something else. Asymptote. Good. Y equals -4. Liam, pick something else. Pick one. We're filling in.
It's concave down.
Good. Concave down. Again, which means, right, that the rate of change is decreasing. Brady, how about increasing or decreasing function? Good. The function is increasing. It's concave down, so that's a decreasing rate. Okay. Parker, limit line or intercepts? All right, I didn't find it yet, so we'll check you. But you're going to take the x-intercept one, because that one's easier. -4, -1/8?
No, 0, comma, negative 4.
Oh. Well, so we'll check that in a second. So what are you telling me it is? 0 what? Oh, I get you. Sorry. I get you. I haven't done that yet, so we'll check it, right? So x-intercept, none, right? How about limit lines? Noah, how about this limit line?
As x versus infinity, the function versus -4.
Good, -4. That is an end behavior, so no superscript. Lauren, how about the other one?
As x goes to negative infinity,
The function what? Good. All right, so let's check Parker on his intercept. All right, so which one was that? So we're plugging in 0 for x. So what do we got? -3 minus 4. So that is -1/8. So he is good. So that one wasn't that bad. All right. All right, is that okay for exponentials, right? So again, those are the harder ones. So are you guys okay with me passing over the easy ones, right? Natural log, just a decay, just a growth. I know these are logs, right? Are you guys okay with me passing over those, right? Those are pretty basic ones. All right, so next thing I want to talk about is that idea of domain. Domain. So these are our log functions. Log functions. I know the directions say transformations, but I'm going to change it a little bit. All right, so if I take this one, right, I need to find the domain. I could verify it by doing some transformations. It is a log growth. It does go left 2. So that means I'm going to take my asymptote. I'm going to take my point. Right? Those are the only things we need to really look at. And I am going to move those left 2. And then I do a y-axis reflection. So my final graph on this, y-axis reflection is going to move that to the right 2. And it's going to move that point. So if I do my domain from my picture, it should be negative infinity up to 2 being open. All right, so if I do it algebraically, I got to take the argument and set it greater than 0. So algebraically, it does verify. So I'm going to give myself the, whoops, not that one, not that one, not that one, these. So first one is really easy. Find the domain. Second and third are a little harder. Find the domain. No graphing these. No graphing. So find the domain and range algebraically. Find the domain and range algebraically, please. We are like flying through this stuff. So again, my goal for today was to do the harder stuff, right? you want to check the first one with a sketch, you can, but no graphing calculator.
Yeah, it was like, that doesn't make sense.
First one should be relatively easy. Second one, that brings up last section, rational inequalities. Third one, absolute value makes it nice, but you just got to think a little bit on that one. So how about the first one? First one. Naya, what you get? First one. Negative 5 to infinity. So algebraically, I can take the argument, make it greater than 0, and I'm getting negative 5 to infinity. So if I sketch it to verify it, log growth, I'm going left 5, so all I need to do is move that asymptote 5 units, and there's my graph. Anybody want to try on the second one? It's a hard one. It's a very small domain. Negative 1 to 1, very good. Negative 1 to 1. We'll go over it in a second. How about the last one? Anybody want to try on the last one? Everything but what? Good, Noah. Everything but 2. Right? Everything but 2. Everything but 2. Right? So for the second one, I need to take the argument, set it greater than 0, and solve it. So this one is last section. Right? Last section. I can't multiply by the x plus 1 and get rid of it because that takes a whole section of answers out. So you need to say negative 1, 1. The bottom is a normal sine graph. The top is a flipped sine graph, right? Because a negative x. So negatives to the right, positives to the left. I need it to be positive, so only the middle section. Okay? So no, why not 2 in this one? Because absolute value, that's always positive. I should be good. Good. So it can't be 0. So on this one, Max, I probably set it equal to 0, right? And say 2 is going to make it 0. So I need to take that out of my domain. I want you to realize that these graphs look a little weird. So I took the first one, right? And here's my first one. This one is not weird. Log base 2 of x. Well, this one's a little weird. And this is my graph. Does that graph look like my sketch? Does that graph look like my sketch? Ryan, what do you think? What's the matter with the calculator one? The line stops. Why does the line stop in the calculator? Why does the line stop? Does it really stop? It doesn't stop, right? So this is why I said on your prior knowledge sheets, right, that you kind of have to make sure you're interpreting, and this is why, if you guys used your calculator on the prior knowledge, you had it stop. You have to interpret it, and it does go on forever. So on a lot of I said, make sure you have arrowheads. The graph doesn't stop, right? The only reason it stops is because it can't color in the little boxes. It can't color in a half of a box. Okay? So it is a pixel issue. Pixel issue. All right, so what I want you guys to do, everybody's in pairs. So one person put B in, one person put C in, and verify that we got the domains okay. So somebody do B, somebody do C. Absolute value is math arrow over number. No clue. I don't know. Does anybody else calculated that you have this version, right? So Mac does this version. When you use log base, does it say log base or does it give you the little fill in? It gives you a fill in. Can I look at your operating system? No. We can go second plus. Yeah, you've got a 5.3 operating system. I bet you that's why. If you update it to get the other operating system, it would work. So if you have lunch, anybody remember how to update the operating system? I can figure it out. If at lunch Max just wants to share calculators and we can update it, it will update by then. Okay? I think I have some of that one. So I don't know, Donovan, I would go, I would do the change of base to make it work. I'd go, which one are you doing? You're doing 5? Or are you just trying A?
No, I was doing C.
C? So if you do log of absolute value of x minus 2 divided by log of a half, it will be the same. Change base rule.
What is this?
Right? But is that right? I don't think you have it right. Is that what you're going to put in another one? Oh yeah, you need 3. I would put in another one here too. So it's in 6. Yep. All right, you guys got those graphs in there? Right? So again, you need to interpret the graph. Interpret the graph. So B, does it show the domain from, so you guys should be sharing the graph, show each other, right? Does the domain show that it's -1 to 1? Does the domain show that? What does it look like? It's like a cubit. Does it stop, Parker? Do you think it's supposed to stop? No, it's not supposed to stop. So make sure you're looking at this one because I think this one is worse than the other one. Right? So this one looks like this little squiggle and that's it. Right? But it does not stop. To prove to you that it doesn't stop, right? To prove to you that it doesn't stop, go to second window. Start your table at -1 and go by change the table point 0, 0, 0, 0, 0, 0, 0. How many zeros you want? 1. And again, only one person needs to do that. Then go to your table, second graph. Go to second graph, your table. And even, you might put too many, Parker put too many zeros. He was overzealous there, but that's okay. You can arrow down. So if in your X column, it probably gives you a whole bunch of -1s. But if you notice on the bottom of it, it shows the decimals. And again, does it stop? Right? So on Parker's, he's got 0.999999933, right? And it gives it as 19 point something something. Right? right? So again, make sure you guys are looking at that it doesn't stop. Claudia, what did yours look like?
Mine kind of like up at 2.
I gotta make sure I do it in the right order. Right? What does this one look like? How do you describe that graph? Remember the old way you drew like birds? Like a little seagull? Do you remember drawing them like that? You don't remember that? Come on, the other class said totally. You don't remember like drawing like birds like that when you were younger? You guys are too artistic, right? But do you think it has a sharp point there? Does it have a sharp point? It doesn't, right? So you've got to realize that there is an asymptote there, and that is what it looks like. Write limit lines for this one. Write limit lines for C. Limit lines for C. Limit lines for C. And I guess I'm saying, when I say limit lines, right, I know you guys totally know what I mean by limit statements, but I guess I should really say limit statements. I said that to another math teacher, and they're like, what do you mean limit lines? I'm like, limit of f(x). So I probably should say limit statements. You got 4 arrowheads, so you should be writing 4 of them. You could probably narrow down to 3 of them. All right, so if I label these limit lines 1, 2, 3, 4, Grady, do you think I can combine any? 1 and 4, end behavior, right? End behavior. So, Maxwell, what would 1 and 4 be, the limit lines? Put them together. 1 and 4. Limit of f of x goes where as x goes where? Look at the arrowheads. Are they going down? As x goes to? As x goes to positive and negative infinity, right? That's the purpose of me putting them together, okay? So the ones on the vertical asymptote, right? Right now, we still got to put them separate. Lauren, how about 2? Limit of f of x goes where as x goes where?
As x approaches 2 on the left side,
Good?
then f of x approaches 1.
Good. So 2 on the right, I go to infinity, and then, Molly, how do I change it for 3? Ooh, no, I said 2 for you. I don't remember what I heard. It should be left. Yeah, sorry, I don't know if you said left. Molly, I gave you the answer to the next one, right? So 3 would be 2 to the right, goes to infinity. Is that okay? Are those good? All right, when we come back, we will continue. We have like 1 or 2 more slides. All right, so we just left, right? And we were looking at all of these domains, all right? So now without a calculator, match them. It's really not that hard. Without a calculator, give them a match. So which one is once you kind of define one, you can kind of get the rest of them pretty quickly. Check with someone, see if you agree with the order.
And he didn't even talk about this.
All right, what's the order of the letters? What does it start with? C, right? What's the rest of them? Is that right? That's a B. Is that right? C, A, B, C? Okay, so nice and easy. Okay, so I think I have one more, okay, but I think I'm going to change it. Oh, okay? So I'm gonna change it, right? It says if we have this idea, right? We're investing $1,000 compounded continuously. So we are going to review all of our kind of like money formulas, and then we're going to add them. I'm sorry, we're going to add a couple in. So we have these 4 sections that are some prior knowledge, and again, kind of adding the harder ones in. Then we're going to have a whole section of modeling, which that's what I'm going to handle these, right? So our compounding continuous formula, I don't know if you remember, is A equals P times E to the RT, right? Our E there. So if I invest $1,000 at 6.25 compounded continuously, find these 2 questions. So how much money after 5 years and then how long to double? So that just kind of brings, how long to double? That kind of brings you into changing forms and solving, which is our next part. So answer those 2, please. Answer those 2, please. All right, so the formula is given. I don't need to give you a rate. How much did you guys get after 5 years? I don't remember my answer now. 13 something, right? Wasn't it? Was it? What was it, Laura? 5,000? 1,366. Point. One more? 84?
Or 837, sorry.
8377. So I'll say 838. Right? Is that okay?
Yeah.
Right? So again, 3 decimal places, totally okay. If you want to do money, only 2, makes sense. So hopefully after that, right, you can realize it is going to be more than 5 years to double. Does anybody want me to show you the algebra for part A? That was easy, right? We didn't just plug in 5. And then on the second one, you need to change it to a natural log. What was it, 11 point something? Was it 11 point something? I think so. What did you get, Connor?
Things like 11 point.
Yeah, I think I remember that. 11.09 years. Okay, does anybody want to see either of those? Either of those. B. So how long to double? So we started with 1,000. So really, I'm looking how to get 2,000. But when you take the 1,000 and divide it, you're just getting the doubling rate there, right? So E0625T. So then since it's the base of E, you need to change it to natural log. Natural log of 2 of 0.0625T, we're dividing by 0.0625, right? So me just kind of thinking towards your quizzes, if I gave you a calculator, you would totally get decimals for that. If I didn't give you a calculator, then you would just leave it like this and you would leave it in your log form. Okay, is that okay? Any issues, anything that we did today? So tonight's homework, right, is the other 2 worksheets in your packet, right? And it's starting talking about going over some properties. I never remember any of these properties, right? Because they really just help you with changing forms. But some of the other properties will definitely help. So there are some things that you're solving in equations on the worksheets that if you need them, right? Like there's like a weird factoring one that if you need help with that, totally fine, put it on the homework log, okay? So tomorrow's class probably will be a little, we see each other tomorrow, yes, will be a little quicker, right? So tonight you have the 2 worksheets from prior knowledge. Tomorrow we will finish this section, then over the weekend you'll have